Today I want us to do a topic called matrix. This is a highly examinable area, both in KCSE and also in Cambridge, that is in O levels and A levels. So, to begin with, what is a matrix? Now, when you talk about a matrix is a rectangular array with arrangements in rows and columns. So when you have those entities arranged in row and or columns, then we are talking about a matrix. For example, I can decide and maybe form a matrix using maybe some letters. Let's say, for instance, I have a matrix A, B, C, D. This is an example of a matrix. Now that is an example of a matrix, and in that matrix, remember we said that a matrix, it is a rectangular array which contain numbers or materials that are arranged in either row or column. So when you talk about the row, when I'm going from up to down or up to down, that specific direction, this one we call it the what? We call it the column. This one is the column. Then when we go across, we call it the what? We call it the row. Now, this one is going to be very, very important, especially whenever you'll need to multiply matrices, because that is one of the main areas that is usually tested, multiplication of matrices. So, let's begin. Now, example of matrices, now that contains numbers, that one, it was having letters. Now, if you want to have a matrix that contains numbers, we can have a matrix like maybe 4, 3, 6, 2. This is a type of a matrix. And this is a matrix that has 2 rows and 2 columns. This type of matrix is called a 2 by 2 matrix. This one is a 2 by 2 matrix, which means it has 2 rows and 2 columns. Another type of matrix we can have a matrix that looks like this. 3, 9. This is also another type of matrix. This type of matrix, we call it a 2 by 1 matrix. Why do we call it a 2 by 1 matrix? Because it has 2 columns and 1 row. That is the reason why we call it a 2 by 1 matrix. We have another type of matrix, which is, we can have maybe 3, 4, 6, 2, 1, 1. This is also another type of matrix. There are quite a number, there is quite a number of examples of matrices. Yeah, that type of matrix, now that one will be said to be a 2 by 3. A 2 by 3 matrix, which means it has 2 rows and 3 columns. Now, let us now begin by operation of matrices. And under operation of matrices, I want us to begin by addition of matrices. We are going to begin with addition of matrices. We're going to start with addition and subtraction. Addition and subtraction. Now, under addition and subtraction, this is very basic, very, very simple. Why? Now, this is because whenever we are adding or subtracting matrices, we are going to focus on the position of each number in that matrix. For example, let's say, for instance, I have a matrix like 2, 3, 5, 7. I've been told to add this matrix to another matrix, which is 7, 2, 1, 3. So, the only way you can add matrix number 1 is that you have to make sure that the 2 matrices you're adding or subtracting have the same number of column and rows. In our case here, we can add both of these 2 matrices. Why? Because they have the same number of rows and columns. Both of them have 2 rows and 2 columns, which means this one is a 2 by 2 matrix addition. So in this specific case, if I want to add the matrix, you usually determine their position. Like for instance, number 2 is located on the same position as 7 on the other matrix. So that position, or what I'll do now, I'll come here, ask myself, 2, when I add it to 7, what am I going to have? I'm going to have there 9. Again, 3 and 2 are located on the same position on those 2 different matrices. So it means that I'm going to take 2 plus 3 plus 2 to get 5. Then again, for the 5, I'm going to have here 5 added with 1, whereby I'll have 6, because 5 and 1 are in the same position, on those two different matrices, and also 7 and 3 are located on the same position on those matrices, which means if I add 7 plus 3, I'm going to have 10. So it means that the addition of matrix 2, 3, 5, 7 and matrix 7, 2, 1, 3 is going to give us a matrix 9, 5, 6, 10. Now, what I want you to realize is that when you add a 2 by 2 matrix and another 2 by 2 matrix, you are going to end up having a 2 by 2 matrix. You cannot have any other form of matrix other than whatever you've added. For instance, if I have a matrix like this, 3, 1, negative 5, negative 2, negative 1, negative 7. I've been told to add it 2. So because this one is a 3 by 2 matrix, I can only add it to a 3 by 2 matrix, which means I can have another matrix which is maybe negative 5, negative 2, 8, negative 7, 3, 5. Now, in this case, what am I going to have as my answer? Now, first of all, I'll come here. 3, when I add it to negative 5, first of all, this positive and this negative is going to form a negative. So 3, when I subtract 5, what am I going to have? I'm going to have negative 2. I'll write negative 2 there. Why have I combined 3 and negative 5? Because they are on the same position on those two different matrices. Then again, I'll come to 1 and negative 2. 1 added to negative 2, that is going to be negative 1. I'll write my negative 1 there. Then again, negative 5 added to 8. I'm going to have, that is going to be 3. We are going to have there 3. Then I'm going to have here negative 2 plus negative 7. That is going to be positive, negative, that is going to be a negative. So negative 2, negative 7, that is going to be negative 9. Then finally, we are going to have negative 1, 3. I'm going to negative 1 plus 3. I'm going to have there 2. And finally, negative 7 plus 5. I'm going to have there negative 2. And that is the addition of matrices. What about subtraction? Let us try one example that contains subtraction. So, one example that contains subtraction, we are going to have a matrix like this. Still remember that for you to either add or subtract matrices, those matrices must have the same column and row. So the same will apply on subtraction. For subtraction, let's say for instance I have a matrix like, let's say for instance negative 10, 5, negative 3, 6, maybe negative 2, negative 5. Subtract another matrix. Maybe we have a matrix like 5, negative 3, 3, 4, negative 2, negative 1. What am I going to have? Now, in this specific case, we are having a 2 by 3 matrix on both ends. And remember, what we were doing during the addition, we are also going to do it under subtraction, whereby each and every position in that specific matrix, on each of those two matrices, are going to determine what we are going to have as our answer. So it means that in this case, negative 10, I can only combine it with 5 because they are in the same position on those different matrices. So let us start by the subtraction. Negative 10, subtract 5, I'm going to have negative 15 there. Then 5, subtract negative 3, I'm going to have negative 8 right there. Then negative 2 minus 3, I'm going to have negative 5 there. And I'm done with the upper row. Then I go to the lower row. Negative 3, subtract 4, I'm going to have negative 3, subtract 4, just a minute. Here was negative 10 minus 5. No, it's not, yeah, that is negative 15, good. That is 5 minus negative 3, that is supposed to be positive 8, sorry for that. That's supposed to be positive 8. Then negative 2 minus 3, that is supposed to be negative 5. That is good. Then on the lower row, we are going to have here negative 3 minus 4. I'm going to have there negative 7. Then 6 minus negative 2, that one is going to be 8. And then negative 5 minus negative 1, that is going to be negative 4. And that is our answer. We've subtracted a 2 by 3 matrix. Let us try another one. Let's say, for instance, I have 5, 3, 4, negative 6, plus, minus. So, minus negative 6, 6, negative 5, 4. Let us try that together. Now, with that, we are going to subtract. That is 5 minus 6, that is going to be 11. Then I'm going to have here 3 minus 6, that is going to be negative 3. Then I'm going to have here 4 minus negative 5, that is going to be 9. And finally, negative 6 minus 4, I'm going to have that as negative 10. So always remember, when either adding or subtracting, there you always have to consider the position of each of the number in that matrix. And also remember that you can only add matrices which are in the same form. In this case, you've seen me adding a 3 by 3 matrix. You've seen me adding a 2 by 2 matrix. You can add a 2 by 1 matrix. So only those that have the same row, the same number of row and column, and can be added or subtracted. So I want to give you some 2 or 3 examples for you to try. So I want you to try these ones. So you'll try this as your assignment. You'll try this as your assignment. So you're going to work out question number A. Maybe we can have something like negative 2, negative 3, negative 5, negative 4, 6, 10, plus maybe 5, negative 6, negative 2, negative 4, 5, 11, minus 2, 1, 5, negative 3, negative 3, negative 4. So you'll try work out that, and also this second one. So this one we can work it out because all of them, they have the same entities, the same number of rows and the same number of columns. So you're just going to identify the position of each of the numbers, then you combine them with their respective sign. So you can also try this: 2, negative 5, negative 3, negative 4, minus 5, negative 9, negative 3, negative 11, minus 2, negative 2, 5, negative 5. And let's have a break, then we come back for the next session. So I hope that the assignment was done and was done correctly. If there is any problem, you can just reach out to us for more help. So let us continue with matrix. So in our previous session, we did look at addition and subtraction of matrices. So today we are going to look at multiplication of matrices. Multiplication of matrices. Now, most of the students usually have a problem on multiplication of matrices, but this is an area which is very, very simple and very, very easy to understand. So let us try and work it out. Multiplication of matrices. Now, when we'll be multiplying a matrix, first of all, you always have to consider the row and the column. Now, let's say, for instance, I have a matrix A, B, C, D. This is a representation of a matrix in form of an algebraic expression. Then I want to multiply it by another matrix which is E, F, G, H. Now what am I going to do? Now, number one, you have to know, or you have to identify, in each of the matrix, you have to identify the row and the column. Now, one thing about multiplication of matrices is that you can multiply another matrix, one form of a matrix with another form of a matrix. So the two forms they don't have to be the same. You can multiply a 2 by 2 matrix by a 2 by 1 matrix. You can multiply a 2 by 3 matrix by a 2 by 2 matrix. So you can basically multiply any matrix with another one. So in this specific case, I want us now to form a general multiplication of a matrix using these two algebraic representation of the matrix. So I'm having the first matrix as A, B, C, D, and my second matrix to be E, F, G, H, of which both of the matrix are 2 by 2 matrix. Now, remember, whenever you want to multiply matrices, you have to identify the row and the column, because multiplication of matrices involves multiplication of row and column. Now, what do I mean it involves the multiplication of row and column? So if you decide that you're going to follow the row on this matrix, you are going to follow the column on this matrix. Remember, we said that this one is the row and this one is the column. Now, let me do the illustration. So first of all, I'm going to start with the upper one. So this row, I'm going to multiply it first of all with both the columns. So let me first of all start with multiplying this row and this first column. So A multiplied by E, I'm going to have there AE, plus B multiplied by G. So you multiply this row with the whole of the first column first before you go to the next column. So here I'm going to have B multiplied by G. I'm going to have here BG. I'm done with the first one. I'll still have the first column. I have to do the first column with the first row, then the first column with the second row. So because I'm done with the first column and the first row, I'm going to go with still the first column and do it with the second row, so that it can give me the second position. So we are done with the first row, we are done with the first column, and the first row with the first column. So we go to the first row again with the second column, whereby now I'm going to come here, say A multiplied by F, it is going to be AF. And again, B multiplied by H, I'm going to have there plus BH, plus BH. And now I'm done with the first row. I'm done with the first row. Let me now go in my first matrix. Let me now go to the second row. This second row, I'm going to multiply also it with the first column and also the second column. So I'll come here, say C multiplied by E will give me CE there. Then B multiplied by G, I'm going to have the here plus BG. Then again, this row multiplied by the second column, which means I'm going to have here C multiplied by F is going to be CF, plus D multiplied by H. I'm going to have there DH. And that is how we represent the multiplication of matrices. What I want you to remember is that we always do the row and the column. We always do the row and the column. So here I choose the row. If I choose here the row, I'm going to work with the column on this other end. You always have to make sure you multiply this row with the two columns before you go to the other row. So always remember that. Now let us try that multiplication now using actual numbers. There we were using algebraic representation. Let us now try using actual numbers. Suppose I've been given a matrix like maybe 5, 3, 4, 2. I've been told to multiply that matrix with another matrix which is maybe 7, 1, 2, 4. I have those two matrices. I'm being told to multiply them. Now, how am I going to do that? Number one, remember, you have to identify the row and the column. In your first matrix, we are going to identify this row. And this row, I'm going to multiply it by all the two columns before I proceed to the second row in my first matrix. So let me begin. 5 multiplied by 7, I'm going to have there 35. Then plus 3 multiplied by 2, I'll have there 6. I'm done with the first, I'm done multiplying the first row and the first column. I'll again go the first row and the second column, whereby I'll come here and say 5 multiplied by 1, I'm going to have there 5 plus 3 multiplied by 4, I'll have there 12. I'm done with the first row. I'm done with the first row on the first matrix with both the columns on the second matrix. Then now I'll come to the second row. I'll also do the same with the first column on the second matrix and the second column on the second matrix. Then I'll come here and start 4 multiplied by 7, I'll have there 14. I'll write there 14 plus 2 multiplied by 2, I'll have there 4. Then the second column, I'll have here 4 multiplied by 1. It is going to be 4 plus 2 multiplied by 4. I'm going to have there 8. Which means if I add that, I'm going to have 35 plus 6, I'm going to have there 41. 5 plus 12, I'm going to have there 17. 14 plus 4, I'm going to have there 18. Then 4 plus 8, I'm going to have there 12. And that is my multiplication of the matrix, as simple as such. Let us try another example. I'll just wrap this one. Let us try another example. So what you have to identify is the row and the column. And the row that you identify of the first matrix, you have to multiply it by both the column on the second matrix before you proceed with the second row and the second column, the first and the second column. Suppose I have a number like -2, -5, -6, -3. I'm being told to multiply this with -5, 2, 4, -3. What am I going to have there? Now, remember, I've said you have to start with the first row and the first column, the first row and the second column. Once you're done with the row, with the first row is when you go to the second row. Now let us begin. The first row, this is the first row. I'm going to multiply with the first column and the second column. So I'm going to have here -2 multiplied by -5, that is going to be 10. Then -5 multiplied by 4, that is going to be plus -20. Next, the first row with the second column, whereby I'm going to have -2 multiplied by 2, that is going to be -4 plus -5 multiplied by -3, that is going to be 15. That is going to be 15. And I'm done with the upper one. I go to the lower row. I multiply also with both the columns. I start here. -6 multiplied by -5, that is going to be 30 plus -3 multiplied by 4, that is going to be -12. I'm done with the first one, with the second row and the first column. So I go to the second row and the second column, whereby I'm going to have here -6 multiplied by 2, I'm going to have -12 plus -3 multiplied by -3, I'm going to have there 9. Then now let us now combine them by the addition. 10 minus 20, that is going to be -10. Then there we are going to have -4 plus 15, we are going to have there 11. Then 30 plus -12, we are going to have there 18. Then -12 plus 9, we are going to have there -3. And our multiplication of -2, -5, -6, -3 matrix and -5, 2, 4, -3 matrix, we are going to have our final answer as -10, 11, 18, -3. So this one is multiplication of a matrix and another matrix. Suppose you've been given a matrix like this. 5, -5, 2, -3, with another matrix like this, 3, 4. Now, what are you going to have there? Now, you can see, remember I've told you that with multiplication of matrices, you can multiply a 2 by 2 matrix and a 2 by 1 matrix. This one is a 2 by 2 matrix, this one is a 2 by 1 matrix. We can multiply the two because I've said multiplication does not really matter the type of matrix we are having. So in this case, we can multiply these two matrices. And what are we going to do? Remember, the same thing applies, row and the column. So it means that this first row, I'm going to multiply it with the column. So it means that on my second matrix, I only have one column. So it means that I'm only going to go one. So 5 multiplied by 3, I'm going to have 15. Then plus -5 multiplied by 4, I'm going to have -20. I'm done with that one. I go to the downer one now. With the downer one, it is going to be 2 multiplied by 3, which is going to be 6, plus -3 multiplied by 4, which is going to be -12. Which means what I'm going to have here as my summation, or as my product of those two matrices, it is going to be 15 plus -20, that is going to be -5. And then 6 plus -12, that is going to be -6. So it means that the multiplication or the product of matrix 5, -5, 2, -3, and 3, 4, the product is going to be -5, -6. Let us try another one involving a 2 by 1 matrix. Let us have another one. With this kind of working, really require a lot of practice. So once you do it here, you need to do quite a lot of practice. So suppose you've been given a matrix like this. You've been given a matrix like maybe 3, 5, 4, 2. You're being told to multiply that matrix with matrix 5, -7, 2, -5. That kind of matrix. What are we going to have there? Now, I'm going to have here 3 multiplied by 5. Remember, row and column. So the first row, I multiply it with the whole of the first column, and the second column is when I go to the second row, the first column and the second column. So let us begin. 3 multiplied by 5, that is going to be 15, plus 5 multiplied by 2, sorry about that. 5 multiplied by 2, we are going to have plus 10 there. Then we go again, 3 multiplied by -7, we are going to have there -21. Then 5 multiplied by -5, we are going to have there -25. And we are done with the first row for our answer. We go to the row below. That is 4 multiplied by 5, we are going to have there 20, plus 2 multiplied by 2, we are going to have there 4. Then on the second part, we are going to have here 4 multiplied by -7, that is going to be -28, plus 2 multiplied by -5, we are going to have there -10. Then now we add, what am I going to have? 15 plus 10, that is going to be 25. Then -21. -25, that is going to be -46. Then 20 plus 4, I'm going to have there 24. Then -28 plus -10, that is going to be -38. That is going to be -38. 8, and that is going to be the what? That is going to be the product between those two matrices. Now, apart from having a matrix and a matrix multiplication, sometimes you can have a matrix and a whole number multiplication. Now, a matrix and a whole number multiplication, this involves where you're having a whole number or a number, not specifically a whole number. It can be a fraction, it can be a decimal, but you're having a number, then you want to multiply it with the matrix. For example, let's say for instance I have something like this. This is now another type of multiplication that involves matrices. So we have this type of multiplication. Let's say for instance you have there maybe 5 over 7. Then you multiply it by a matrix, maybe negative 14, 7, maybe 42, 28. Now what are we going to do? We are going to multiply this number that is on the outer part of that matrix. You are going to multiply it with whatever is in the matrix individually, which means I'm going to start by 14 over 7, 5 over 7 multiplied by negative 14. 5 over 7 multiplied by negative 14. So in this specific case, I've said you're going to multiply this fraction or this number with each of the numbers inside the matrix. So I'm going to have here 5 over 7 multiplied by negative 14. 7 goes into negative 14, negative 2 times. Negative 2 multiplied by 5, we're going to have there negative 10. Then here 7 and 7 will cancel. I'll remain there with 5. Then we're going to have here 5 and 7 multiplied by 42. 7 goes into 42 6 times. 6 times 5, that is going to be 30. Then 5 over 7 multiplied by 28. 7 goes into 28 4 times. 4 times 5, that is going to be 20. And that is our matrix. So we've multiplied a number and a matrix. A number and a matrix to get that specific matrix. That is another multiplication of matrices that we can have. So with that, I want you to try this as your assignment. I'll only give you one question as assignment. So you've been told, given that P equals negative 2, negative 3, 4, negative 6, and R equals negative 3, negative 3, 5, 2. Then you've been told, work out the value of M, which is given us, 2 over 3 P minus PR. You will try work out that, then we'll meet in our next lesson. Thank you very much and have a good day.